Саботировать можно?
Okay. Okay, guys, let's start with some basics. So, what I told, uh, all can see my presentation. Yeah, right now I launch a
Yep.
presentation. So, today I would like to talk to you about distributed system. We'll touch up such system as Kafka, Hadoop, Redis, Cassandra. Um, so, let's start with some basic stuff. So why do we need a distributed system? So first of all, we all, I think, know we're working in the fintech sphere, so we know then data is more valuable than HD space. So for example, 1 GB in data center usually costs about 50 cents. And if we're talking about lost data, it's costs really much more. And second of this, for system, for business critical, for mission critical system, so it's 4 nines. Its requirements very strict and required to program be located in different data center for. Uh, so in order for application to be working across different data center correctly, we need something to share data without with mm, two different servers in the different data centers. So distributed system, by the way, for provide such features as high availability, high throughput, durability. For example, if we're talking about Hadoop, we're talking about it a little bit later. It can be like stream of terabytes data simultaneously. So no distributed system can't handle this, such as high throughput. um, that I think. So let's consider some hypothetical system. So it's like usual system, what we all do, we can do on our laptop, for example. It's only one data center, bunch of microservices, placed in OpenShift cluster. And for storage data, we have some storage system. It doesn't matter what kind of storage system we have right now. So what happens if our storage system fails? Of course, our users get nothing, and it's been denied of services. So if we lost data in a storage system permanently, it can be happen even in cloud in the cloud storage systems. Yeah, it's been a really tough thing to do for users, because if user use our application for store his personal information, maybe photo or video, it's been bummer for him, and I don't think he can use our application more than one time. Yeah. So how we can solve this problem? So we just add some copy of our storage system, yeah, and it's work, I think, perfectly. If we just lose one of copy storage system, we always can just switch to another, and we didn't lose data. And if we can switch it automatically, for example, OpenShift can do this. We just users maybe just didn't even notice something went wrong. Yeah, and it's been like positive experience for users. Yeah, but what happened if we are migrating our data center into the cloud in this particular way? Of course, it's didn't work at all, and the worst thing, we just lose all clients' data, even if we have some distributed system working only on that one data center. Actually, it is really a data center. So um, so that's it. So what should do to avoid this kind of situation and migrate our application to data center correctly? So we just use another data center. So in this particular way, load balancer it can be anything actually. It can be VRRP, a technology based on IP and some special routers. It's really bugging, but still it can be it working. But for our situation, it can be just I don't know, Altova, for example. It's hardware for placed on some data center, and this hardware can be have two different thing in distributed clusters. Stretched cluster, for example. If we have stretched cluster between two data center, we can just use Nginx, for example, for load balancing. So we had just load balancing, we had Nginx to just have two different storage system. You can see it's just not connected one to each other if we're talking about data center. So it can be only business critical system in load balancer working only an active passive mode. So how we can do this communication, I think that's a real question, and each distributed system can answer it in his own way. So for intro, that's all. Let's just start with minio. Um, so briefly, how it works inside. So it's a S3 compatible object storage. We can store in this system very large files because all files just divided into separate blocks and they put in a different storage. You can see its data here. So what's a really bummer in Minio? We have only limited servers to install. It's only 32 Minio servers in one pool. Pool, it's like different Minio cluster. If we place file in one pool, it's didn't replicate to another pool. Just for administrative issue, for example. Yeah, what how it working inside. So we have, let's consider we have like large file, like 1 gigabit, maybe video or something like this. So Minio just divided into similar pieces, a little pieces about, I know we can set it, but I think it's about 10 or 50 megabits blocks. So with each block, we do this whole file actually. We do some magic. It's called erasure coding at Reed Solomon code. So what's happened in this code? We just add some really magic thing, like mathematics, really long mathematics string, and it can help us to restore information if we lose nearly half of copies of files. So we just have 1 gigabit file. If we lost like 499 megabit information, like anything in this file, we can restore our file with this mathematical code. If you want to hear about it more, we can just discuss it later. So it can be it cost about 2 times more if we're talking about size of files. So 1 gigabit file after erasure coding will be like 2 gigabit file. That's next. We have in Minio we can set our replication parameter, how many replica we can store in our system. So maybe it's like 3, for example. It's I think a common thing to if we're talking about high availability and durability. So it can be like multiplied by 3 actually. So our gigabyte file can be right now like 6 GB file. But it's like divided for whole our nodes and data centers. Bitrot protection, highway hash. Highway hash, it's a really fast hashing function. It it came with some cost, but still we can use it for just really fast hash, fast hash from a file. So bitrot protection actually is just we take our replica from pool and we just check hash changed or not. If hash changed, we just remove this replica and copy from another copy from another replica. Yeah, that's why we can just keep our files untouched. In minio has encryption with KMS. It can be like client-side or server-side encryption. Um, minio has minio and I think much more. I think all of them distributed system has this thing called worm. It's write once, read many times. So we can't edit blocks what we put in the system. It's always be a new block. We can connect Minio to Active Directory or Cake-log easily. Yeah, and I already told you about 32 servers restriction in one pool, but for honest, it's limited only servers. So if we're talking about we wanna add more HDD, for example, yeah, it's not limited. So we can in one service we can like thousand of HDD to store data. And one thing I wanna tell you about all HDD in pool should be a same size, because if we, for example, has I don't know 10 terabytes, 10 disks by terabyte, and only one disk for I don't know 100 megabyte, all cluster be reduced to 100 megabytes. So we just lose some spaces, and it's not okay. So cluster can't be get roses. Okay, cluster should be like cluster should be Gomo. Okay, that's how. So it's just example how we put our Minio in our architecture. Minio is Kubernetes native, so it's easy to install in OpenShift cluster, for example, and OpenShift can rule Minio servers actually as a usual microservices. So that's like a picture how we can use it. So doesn't matter which kind of Minio server we connect, it can be appear in any of them. So for reading and writing Nginx, we um, configure like last connection pool. So I have a question for you guys. What's happened? What's this problem in this particular scheme? What's happened if we just lose our 1 hour data centers? Anyone?
I think we should uh, create new replicas to make our system stable.
No. For example, it's not about replica. For example, we just lost
network rebalancing and KMS. I don't know. It's in two data centers in one implementation. What is? If we lose one data center, we will rebalance all data from this data center. We need to store some replicas in, I think, free, and that replica should be in one data center. I don't know what configurations, but I think it's much data for network.
Yeah, it is. But what I wanted to push you, it's split brain. So if we just lost connection between data centers, each cluster, each server can be thinking like I'm only survived here. And what we have is data corruption and some different cluster situation. And yeah, how minio handle this situation? For example, minio, if minio server understand he's like in health or less, yeah, in working, he switched to only read-only mode, so we can only have some data from this. Yeah, Andrei, you're talking about some replication. Yeah, it is, but according to Azure coding, we just don't lose any data at all. So if we just lose half our cluster. So
Of course, but if this is OpenShift and virtuals, I think if you store much data in terabytes, that will provide much effect for all microservices in OpenShift. Virtual network, I don't know how to will как сказать правильно справиться.
handle.
I don't know if OpenShift handle this situation.
Yeah, but it can be, because we have a different OpenShift cluster without any touch-up between them. So each of OpenShift cluster can handle his microservices loading. If we talk in business critical system, for example, it always working only one of the clusters. Yeah, one of the shoulder. I don't know. Can I say shoulder? Okay, so if we wanted to avoid this situation, like if connection between data centers lose end, we need to write our files, not reading them. Yeah, read is good still, but we need to write. So we just add some data center and one of like mini very little copy of our server for this one thing, can be one HD for just quorum. It's called quorum. So in this particular situation, if we lose one data center, yeah, completely lose, like he's burnout, yeah. We have always 3 minio servers. We have like a quorum, yeah, and cluster will be working perfectly, by the way. Even if we just has in one data center, the first of 2 data centers, like I don't know, thousand of terabytes information, and for a minio server and data center is like a 1 HD with 100 gigabytes HDD, it still works perfectly. Yeah. So let's go. Okay. This last about Minio. Do you have some question we can discuss if you wanna? If you have a question about Minio.
Alexander, you mean we have to have one server as a leading node, like in Kafka, right?
It's not leading node. It's just a little node in a different class in the data center for quorum. So if we just see which cluster is like available alive, it's not leading. You see, it's just I haven't even draw a line from Nginx to this Minio server, because I don't need to even to ask this particular server about his data. It's only for replication and only for quorum. It's work with all distributed system. We always need to a third node, a little bit, maybe a little one, yeah, a small node, just for see which data center is alive right now.
Okay, thanks.
And what happens if we lose data center 3?
Nothing
with this,
actually.
And we will make quorum?
Yeah, we still had a quorum. If we lose 2 data centers, like 2 and 3, it can be only read-only mode. Yeah, but if we lose only one data center, no matter which data center we lose, we have like minio working as nothing happened actually. This is why distributed system is perfect for this kind of situation, because we always had like 4 servers or 3 servers, yeah, alive. And we can just tell if we only have 5 servers, 3 it's always more than half, yeah, and we working 4 still more than half.
Okay.
Anything else? Okay, let's.
I don't understand why we don't write in minio in quorum data center.
Don't write.
On the read.
Yeah, I know. Data center 3, actually, if we're talking about VTB or Gazprom, for example, what I'm working right now, it's a really expensive data center. Usually, it's using only 4 quorum things for microservices and so on. So it's difficult to, have a much information there, and I don't know. It can be right information to this server too, but I think I wanna avoid to this kind of connection, yeah, or data flow from microservices to this particular service, because it's only purpose to quorum. Yeah, it can work in your.
But why? It's about security. It's about firewalls that could be bottleneck or what.
Good question.
That you thought about minio. He should have same HDDs. I think he should get same CPUs. And that's why servers will be same that in DC1 and DC2.
Yeah, but
He should get same performance that in another nodes in DC1 and DC2. And I think you maybe thought about security, that some ports shouldn't be used. Some firewalls as bottleneck mesh can be expensive. Or what?
No. If we put a little bit much thought in this, okay, we can just connect Nginx with this particular manage. By the way, why I didn't forget, we're talking about a volume of HDD should be the same, like 1 terabyte in the whole cluster. But if we're talking about CPU or something like this, it can be. It's not recommended, by the way, of course, but it can be like a different CPU, and especially it can be like minio server in data center 1 and data center 2 has like, I don't know, 10 HDD with the terabyte, yeah, each one. And in data center 3, we have only 1 HDD for a terabyte, and it works perfectly because of data center.
But it should be same. Then all should.
It should
Minio's HDD
value,
should be
HDD
not.
value. HDD value should be the same. HDD in the size, I mean, size of HDD disks should be the same.
You mean size of each disk,
Yeah.
of each disk, not the whole storage, right?
Yeah.
So okay.
Yeah, it can be like different CPU, but Minio don't recommend it either. It can work, by the way. Yeah. If I draw microservices, for example, in data center 3, yeah, I think I should write some arrows to Minio server. It can be working perfectly if we can switch Nginx, can draw Nginx arrow to Minio server in data center 3. Of course. Why I didn't do this? It's because I think these particular minio servers should be only for quorum purposes. So that's why I don't wanna, you know, put some information in it. I know maybe it's silly, but I think it's like it's one purpose. It's little and one purpose for this particular reason. Yeah, I think I should. I think I should through it a little bit more and maybe. Okay, it's only my silly things to yeah.
I understand, Alexander.
Mhm.
We don't need to discuss.
Mm-hmm.
Okay, Alexander, but the mini server, quorum server, it's not arbitrary, right?
No,
So
no.
if we lose data center 3 with quorum server, we have no losses, right?
Sure, yeah. It's not leader or slave in
It's
Minio.
like it's an option. It's option just for durability, right? If we use
Yeah,
one of main DCs, DC1 or DC2.
yeah. We still have
Mhm.
like quorum and works perfectly without any hiccups.
Okay, thanks.
Mhm. So let's go to the next one. The next one is HDFS or Hadoop. Hadoop distributed file system. What's the difference? It's I think much difference we're talking about if we're talking about different with Minio. So first of all, it's system for store extremely large files. So we're talking about video, for example, gigabytes. For example, YouTube based on HDFS, or many systems who store huge log files or something like this. Um, so why is that? It's because of architecture of this system. We had a central node. We have name node here. This particular node store whole map for each data nodes. So we store their metadata for all files. There we can just find a replica where we just have a name file or something like this. Whole metadata hold here. So if we try to store in HDFS large amount of really little files, we can face with the problem. We can't have afford to store it in our CPU or if our in our RAM in name node, because all files store in RAM here. But still, if clients ask name node and gets all cluster map to himself, name node can be not available, but still client can read or write to this accordingly to this cluster map. So what's a really great thing about HDFS? It's write and read directly from nodes stored in data stored in, and and because we store only large files, the minimum block size is 64 megabytes, and actually sometimes it's set higher. Yeah, we have async replication. So if we read or write something, it's like no delay to replicate information. We can talk about Kafka, so it's a really big difference here. And we still have a warm technology here. So basics, I think we go. So it's about replication too, still the same. So we just had a large file, we just separate to the same block size, and each block we just replicate to different data nodes. So hdfs cluster example here. So one of difference between these systems, name node only can work with the active passive mode. So we can have name node in a different data center, but it's only a slave, and if we need to activate it, we should like put it in our hands. So we didn't need for Quorum the third data center in particular this situation, because if we lose one of data centers, we still can work with data nodes if we had a cluster map, yeah. And if we're talking about active master slave configuration, what I draw here, we just can up name node on cluster 2 and working as usual without any problems. So let's continue. So the one detail here, it's if we're talking about active passive mode with the name node, we should use NFS for store file who can share between nodes. So NFS, it's a bit bit a problem here if we lose on a cluster which contains NFS system. So we can put NFS in stretch cluster, I think, or something like NFS in stretch cluster. It can be work perfectly, but with some problems, some troubles. So that's all about Hadoop. Do you have any questions about that?
Yes, I have a question. Data node stores its own replica of whole data, right? Or no?
No, we divide our big file to blocks, and each data node saves the replica of this block.
But not the whole information, right?
No. This it's divided for clusters evenly.
And what happens if we lose one data node in one?
Nothing actually. We had like 3 replicas on same block around the cluster. If we lose one of the replica, we still have 2.
But if other nodes have the replica, so every data node has all replicas, right? Or no?
No. I only write 4 data nodes here. I don't think it's a real configuration, because data nodes like it can be hundreds of thousands of these around the cluster. Yeah, if we lose some data center who contains if we really unlucky, contains all replica blocks on one replica, yeah, we can lose some data, of course, it is. But if we're talking about 1,000 data nodes across data centers, it's not a real problem, because of it's replicates separately to different data centers. So if we lose one data center, we can just be sure in one data center we have all replicas for one file. So for example, on this particular situation, we have 4 data nodes and replication factor by 3. So each block we store in data nodes in one cluster and 2 data nodes in another cluster. So we lose the whole data center. We still had a 1 replica in one data center, it's in cluster 1.
It's about sharding, of course.
Yeah.
That means we have 3 files divided to blocks and replica free. We don't need store it all on only 3 data nodes. we could store it on every count of nodes. 3 files will be sharded for 100 data nodes.
Yeah,
That's right?
yeah.
Okay.
Okay,
Good.
thank you.
So guys, let's continue. Everyone see my demonstration?
Yeah, now
Yep.
it's about previous theme.
Andrei, I didn't understand what you're saying.
What about previous slide, previous theme?
HDFS cluster example?
Yeah.
Yeah, I think that's all. No, we had some question about HDFS still.
Yeah.
Okay, let's roll it.
NFS, why this protocol? It's very old.
It's like I don't know, a really bummer of this system. I think I read some articles about how to improve this situation because you know it's no draw between name nodes, and they had some shard directory. It's recommend we shard by NFS, yeah, but still we can use some other thing. If we're talking about Ceph, we can use like connect as NFS our Ceph cluster, for example. It can be avoided, but
Okay.
still, like it's a flow of this scheme.
Yeah, thanks. It's because it's about persistent volumes in OpenShift. It's about what protocol. It's about some mount. Why we couldn't use HTTPS or something.
Yeah.
Okay, thanks.
Yeah, you're right. Yeah, it's a bummer. Any other questions, guys? Okay, let's continue. Let's talk through Redis. It's a really simple system if we're talking about distributed systems. So basically, if we're talking about simple database, it's just database to you know, use on your laptop. If we have a high available database, it's like one primary, one replica, replicate asynchronously to a replica from master, and we use only master to write or read data. We have cluster database. We just have a key. It's key value database. You all know, I think. We all working with Redis. Yeah, it can be stored like really wide a range of data structures. It can be like if we talking some I don't know, JSON, for example, for this case, we can just use similar to document-based system and so on. So if you're talking about clustered database, so we had like bunch of hash codes, and we just separate the a range of this hash code evenly between the cluster. So if we're talking about like 5 nodes, so we just divide all hash codes like from 0 to 60,000. I don't know, it's a really large number of hash can be stored here. So it's just divided to evenly ranged, and we can just connect as a client to a particular master node who can store this range of hash. So we just calculate a hash from our key. We see what this hash range in this which particular server, and we can just directly say this server what we want to do this with this data. One of the main reasons we use Redis, it's because of it's really fast. The Redis database store all his information in RAM. Yeah, it's really expensive database. So I will avoid to store a long time data in Redis cluster. Yeah, and I strongly recommend you to avoid a persistence of this. Redis can be a persistent database. It can store whole information in HDD, but it's really impact on productivity of the cluster. So you should avoid this. If you need to store information in HD, and you should be, if you need to be assured your information is persistence, you shouldn't use Redis. I think you think twice about it. So and we have high available cluster database. It's still the same for each master node, for each primary node. We had a replica. We can had a replica for a replica, actually, and we had a couple replicas for one primary node. So it can be like the whole, I don't know, tree, like, for example, replica had a replica had a replica for high availability reasons, maybe. I can show you a little bit of don't really interesting in my imagination architecture, how we can just get something between high availability and persistent without any real impact in the performance of the system. So, and last thing I want to tell you about, it's a Sentinel. The Redis cluster by itself didn't rule, didn't see any other primary replica, and didn't see a replica by its own server, for example. So we use a different program for this. It's called Sentinel. Sentinel, it's installed for another machine. It can be installed with the same machine, but still I didn't recommend it because of security reason and high availability reason. If we lose Redis with Sentinel, it can be a problem for a quorum in the cluster. So this thing, I think all we using Redis, I think we had the same same architecture for this. So we had like 3 nodes, 2 for replica, 1 for master, and these nodes didn't share data actually. So it's like 2 different copy of the data. So if we need to, like, we had like active passive thing, and we need some transfer a data with date of data center 1, dead data center 1 to transfer to another, it can be tricky. So that's my view how you can avoid it. It's shitty idea, I think, but for active passive mode, it can work. This particular architecture I wanted to install, on my work. I think it works perfectly. So what we see here, we see active data center 1. So we always if everything okay, we always sorry guys, we always go to Redis master. But if you have a data center 1 like burnout, and we can in a load balancer switch to passive mode, passive shoulder to be active. We had a replica of a master who can be right now sent in this using the Sentinel. We can like promote this replica to be master, and it still can be available because we had a replica for this particular replica. And if we had a problem with even with the Redis R1, we still had a working cluster. For I use data center 3, how you can see, for Sentinel only. I don't use Redis on this data center because it's not necessary. This architecture seems a little bit tricky, but it's worked perfectly, I think. And if we're talking about active mode, I don't really know how it's working and why we need this active mode in the cache database for cache only purposes. I think if you need active in Redis and you need to share data between data centers, I think you had a wrong instrument for this. So I don't know how to do it without any huge impact on the availability and throughput of the system. So for Redis, that's all. Do you have any question, guys?
No,
I understood
don't
less
understand.
than 0.
Less than 0. Yeah, but it's I don't know. It's simplest of
Thanks.
it's simplest for them. Okay, we can discuss it. Okay, let's continue then. So the last thing I want to talk to you about, it's Kafka. So I don't know. I think all of you guys working with Kafka already. For me, one thing I'm upset of Kafka, I told you about it's later. That's why I want to talk to you about Kafka, actually. Give me a second. Kafka works like a distributed event log and consists this following elements. So it's producer who write a message. It's a Kafka cluster who contains brokers and topics and partitions, and it's zookeeper who just store all cluster information. Yeah, and we had a consumer who just consume some messages. So it's if we try to see a difference in this system to minio, for example, if I'm talking about only about architecture, how it's working. We had here it's a technology called high watermark, and we just what's it's tell us, and we should add. Fuck. Okay, let's go rewind about it. Give me a second to get myself. Okay, let's continue. So we had a broker. Each broker has topics. Topics, it's like queue in if we're talking about MQs. Yeah, but with one really big difference. Topic information, if we put in a topic, if we read in this information, it didn't delete at all. It stores if we before we just delete it manually using, for example, administrative tools. Yeah, but it's called distributed event log actually. So each broker had a bunch of topics, and each topic had the partitions. Partition in its the object really store our message. Partition can be like 3, 5. We can just set how much partition we use. Yeah, and for each partition, we can write for partitions data, and we can read from this using offset. So we just store for each partition. We store in zookeeper offset for the consumer group. Consumer group, if we're talking about it, it's like bunch of consumers who can just consume messages like with separate, I don't know, separate threads. Yeah, but still had a one offset. So it guarantees in one consumer in a consumer group can't read the same message who read another consumer in consumer group for in this one particular topic. So you can read for a bunch of topics simultaneously, but still one consumer can't read another consumer data in the same consumer group. So what we had here? We had here still leader and follower. So for each topic, we just tell which broker is leader, and zookeeper stores this information. For producer, we first of all we need to understand which broker had a leader topic for our partition. Yeah, and we just get information from the keeper and to read information to the leader. After that, leader need to replicate a data. So it's not warm. It's not like we write or and like go through it. It's like we read, we write something. It should be replicate. It can be, of course, it can be configurable, but still, how watermark tell us like for 2 maybe replica, it can't be available for consumer or free replica, or after free replica successfully reads, you can just tell the producer to consumer to you have the new messages in the topic. Yeah. And of course, this configurable how we can produce it, how, and then we can tell producer then our message successfully writes to a partition. I think you understand it's poorly, really. Yeah, I think I need to maybe have a little more time and talking about this topic. But okay, last thing I want to talk about Kafka in this particular topic, and I didn't had an answer for this. It's a geo distribution problem. For main of system, for Cassandra, for example, yeah, we can just say to cluster, like, man, you should get one replica of the file to the another data center, for example. But with Kafka, you didn't have this thing. I didn't know why. So you can just put a broker in the different data centers, sure, but still you can't tell your replica, yeah, your partition install in different data centers. So if you need to be sure one problems in one data center didn't upset your whole cluster, you need to mirror. Documentation says like mirror the whole cluster in another data center. I didn't really think it's a good idea, but I don't know how it's can operate, this really high available cluster mode. So if you had a solution, you can tell me.
You mean we can, in one Kafka cluster, we can't have brokers in different physical data centers?
We can, but how without manually set partitions, yeah, in a different data center manually, like you need to go to configure it manually, partition 1 in this data center, partition 2 in this data center. How do it automatically? I don't really know. Of course, you can just install broker 1, broker 2 in different data center, and it can be work fine. But still, if we're talking about like 10 brokers, you can have a situation partition this replica of this partition be only in one data center.
Okay, you mean you have no ability to directly assign the particular partition to particular data center. You mean this?
Automatically. If you're talking about manually, you can just configure partition 1, partition 2. But if we're talking about like I want to just have some parameters in a config file who tell me like partition should be geo distribution. There is no such thing. If we, and document says if you need to geo distribution, you should have a mirror of whole cluster. Yeah, that's bummer.
Yes, this can be a problem.
Mm-hmm. Any questions, guys?
Nope, I agree.
So I only had a Cassandra. I don't know. It's like, okay, just a couple words. Cassandra has no master. Cassandra designed to go a high throughput. So when we add node, we just add our really increase our throughput. Funny thing, it's communication, a gossip protocol. Each node, like in random moment of time, like ping random node, like 3, 4, 5 nodes, and it can be update a status in the cluster. And that's funny thing. Snitch still, it's technology to like replicate data. It still had replication data. For example, it's key-value database. Yeah, and funny things to say if we're talking about Kafka, you can just use parameter in a Cassandra to tell you need to replica in different data centers. So it's funny thing to do. Yeah, I think that's all, guys.
Oh, data center ring without no master. I have a pain with it. I remember that this is good idea that some node have check another nodes, but not the ring. In the case when the nodes send health check by the ring, the health check will be very high, big, large.
Yeah, sure. Yeah, this problem.
This is probably here. This problem appears.
No, you know, if we're talking about systems, then each node should ping like in heartbeat mode, like each second ping another nodes. If we're talking about thousands of nodes, it can be a really hard thing to do. But still, communication had a gossip protocol. So each node in a random period of time ask for heartbeat a random number of nodes, like 3 or 5. You can install this number. Yeah, like each node in a time, not like heartbeat all his nodes. In nodes send his status to all nodes, but 2 or 3 of them. And algorithmically, we can just assure in some period of time we had cluster to synchronize by itself without any real costs of heartbeat or each node to each other.
Sounds like magic.
A little bit, but no. If you read some more about Gossip Protocol, it's like elegant solution for this really, bummer problem. So guys,
so in every period of time, we infer that, for example, 30% of cluster is working.
No, it's working
for
all
example.
the time. It's working all the time. But if we're talking about how we can find a dead node, for example, yeah, heartbeat, it's for finding a node who just in particular moment didn't working. Yeah, we're using Gossip Protocol. And if we're talking about how we can write and replicate data, it's snitch technology. So like they I don't know, throw information in random time to a random node.
Like in Harry Potter.
Yeah, it is. So guys, I think that's all for today. Just give me a second. Um,